Salam and welcome everyone. So today we're going to be working on the question on your screen that says calculate the value of the change in molar enthalpy minus the change in molar internal energy for the reaction N2 gas plus 3H2 gas gives us 2 molecules of ammonia gas at 298 Kelvin. So basically we're supposed to calculate this information right here, right? This is what we're supposed to calculate, which is just simply the change in molar enthalpy minus the change in molar internal energy. So the first thing you have to notice is that this actually has a full formula. So the change in molar enthalpy minus the change in molar internal energy actually has a formula, which is just the change in Ng value. So the number of moles of the gas times the gas constant times the temperature. So this information right here is equal to this information right here. We already know what R stands for. It's usually the what they call it, the gas constant. And in this question, of course, because we're dealing with internal energy as well as enthalpy, our value is supposed to be in joules. So the gas constant we're supposed to be using is going to be 8.3145 joule per mole Kelvin. And we know the value for temperature because we've been given that to be 298 Kelvin. So what we don't actually have is a change in the number of moles of gases. So we don't have this. But the good thing is that we've been given the equation, so we can actually solve for that. So we have the N2 gas plus 3H2 gas would give you 2NH3 gas. Anyways, so to do that, we have to do the product minus the reactant for this. So basically, the number of moles for the product that are gases. So this one, we have the number of moles for gases for the final or for the product is just simply 2 because we have 2 molecules of ammonia product, right? And then we have this other side where we have the number of moles, okay, of the reactant or the initial reaction or before the reaction took place. So the initial phase, which is before the reaction took place. So the number of moles of reactant. We've got 1 molecule of N2 gas and we've got 3 molecules of hydrogen gas. So 1 plus 3 is simply 4. So we have 4 number of moles for reactant. So anyways, the change in Ng would just simply be 2, okay, because the final minus the initial, minus 4, which is the initial. So 4 is the initial, and of course 2 is the final. So the change in Ng just simply becomes minus 2. So we have all what we need here, right? We can just simply substitute. So the change in the molar enthalpy minus the change in molar internal energy would just simply be minus 2, okay? So the change in Ng, just like we have here, times R, 8.3145 joule per mole Kelvin, times T, which is just temperature, which is 298 Kelvin. So of course you cancel out the Kelvin, cancel out the Kelvin. So changing H of M minus changing UM minus 2 times 8.3145 times 298 Kelvin is simply going to be negative 4955.442 joule per mole. Yep, this is basically the answer. But of course, we know in chemistry, we have to make sure we clean up our work a lot more. What I mean by that, we have to put it in the lowest number of significant figures based on what we were given as numerical value in the question. So if we go back to our question, the numerical value we were given is simply temperature and is in 3 sig figs. So we have to put our final answer in 3 sig figs. So it's going to stop here. So what we end up with is actually negative 4.96 times 10 raised to the power of 3 joule per mole, or negative 4.96 kilojoule per mole. So this is basically the answer to this question. So yeah, that's how you solve this. If you have any questions, please put in the comment section. I am here to help you. If you have any concerns or suggestions, also put in the comment section. If you're a student struggling in any of your STEM related courses, whether you're in middle school, high school, or college, make sure you email me at shohabitutoring@gmail.com. I help students succeed in your STEM related courses, and I'm also here to give you advice and mentorship as you navigate your academic life. I also wanted to mention that what I just solved is from the Atkins Physical Chemistry 11th edition textbook, and there are a bunch of physical chemistry questions I have solved. So look into the description box and click on it to see the playlist for all the questions I have solved. I wish you guys all the very best. Assalamu alaikum wa rahmatullahi wa barakatuh.